Today we are going to solve higher degree polynomials. You have done this a little bit before, but we're going to go a little bit more in depth today. So if you saw something like the first one, x cubed plus 7x squared plus 10x, the first thing you're always going to look for is a GCF. And I can see here that the GCF is an x. So I take it out. If I take it out of the x cubed, I'd be left with an x squared plus 7x plus 10. Then I further look to see if I can factor it further. And I do see that it factors to x plus 5 and x plus 2. When it does say solve, I know these ones don't, but when it says solve, technically you should set it equal to 0. And then once you set it equal to 0, you set all your factors equal to 0. So x equals 0. X plus 5 equals 0, so x equals negative 5. And x plus 2 equals 0, so x equals negative 2. And that's it. Now take a look at the next ones. The first thing we look for is still GCF. Unfortunately, there is not a GCF in all four terms here. When your power is cubed and you have no GCFs, what you do, and we've done it a little already, is factor by grouping. You look at the first two terms, and you see if there's a GCF between x cubed and negative 2x squared. And there is. It is a x squared. When you take an x squared out of the first two terms, you'd be left with an x minus 2. Then you look at your second two terms to see if you have a GCF there. Well, the GCF between 9x and 18 is a 9. Since I said positive 9, I'll put a plus 9 there. When I take a 9 out of 9x, I'm left with an x. And when I take 9 out of 18, I am left with a negative 2. I see that my parentheses match up. Since my parentheses match up, I can write it out in front. And then my second set of parentheses is going to be what's left. It's an x squared plus 9. I cannot factor x minus 2 any further, and I cannot factor x squared plus 9 any further. If it did say solve, I would have to have it set equal to 0, separate it, and you would get x equals 2. And then you have x squared equals negative 9. To solve for x, we take the square root. Well, the square root of negative 9 is plus or minus 3i. The one on the right-hand side here, again, we look for a GCF in all four terms. We don't see it. And the highest power is cubed, so we are left with factor by grouping. So I will take out an x squared from the first two terms, and I'd be left with an x minus 3. And if you look at the second two terms, you have a GCF of a 4. Now, I'm actually going to take out a negative 4 instead, because when I take out a negative 4 out of negative 4x, I'd be left with x. And when I take a negative 4 out of 12, I'd be left with a negative 3. So the reason I took out that negative 4 was so that way my parentheses would match up. Since my parentheses match up, I write it in front. Then I write what's left. If I'm solving, I set it equal to 0. Now I do see x squared minus 4 does factor further. It is a difference of two perfect squares. It factors to x plus 2 and x minus 2. Hold on, I gotta erase. It does not seem to be erasing, so let me just scribble it out, I guess. X minus 2 after it then equals 0. Separate my factors, set them equal to 0 and solve. So I'll get x equals 3. I'll get x equals negative 2. And I will get x equals 2. For the difference of two squares, x to the 4th minus 81. That is considered a difference of two perfect squares. That will factor to x squared plus 9 times x squared minus 9 equals 0. X squared plus 9 does not factor, however x squared minus 9 does. It factors to x plus 3x minus 3. Now we solve, we say x squared will equal negative 9. Take the square root of both sides there, and you'll get x equals plus or minus 3i, and you'll get x equals negative 3, and you'll get x equals 3. Okay, we have 2 more to do. If I look at this first one here, I still look for a GCF, and I see a GCF, it's x. And I would be left with x to the 4th minus 12x squared plus 32. Now I know this looks difficult to factor, but it's actually not that bad. It's just like as if it were x squared minus 12x plus 32. Instead of having an x and an x for my double bubble, though, I'm going to have x squared and x squared. Factors of 32 that add or subtract to a negative 12 are 8 and 4. In order to get to a negative 12, I have to have a negative on both of them. X squared minus 8 does not factor any further. However, x squared minus 4 does. It factors to x plus 2, x minus 2. From there, separate our factors. We'll get x equals 0. X squared equals 8. So when I take the square root, x will equal plus or minus 2 radical 2. X plus 2 equals 0, so x equals negative 2. X minus 2 equals 0, so x equals 2. Same idea on the right-hand side here. There is no GCF. Highest power is to the 4th, so I'm not going to do factor by grouping. Instead, I'm going to try double bubble. Instead of it being an x and an x, I'll make it x squared and x squared. Factors of 64 that add or subtract to a negative 20 are 16 and 4. They do need to be negative to get to that negative 20. X squared minus 16 factors to x plus 4 times x minus 4. X squared minus 4 factors to x minus 2, x plus 2. Set all your factors equal to 0 and solve. You would get x equals negative 4, x equals 4, x equals 2, and x equals negative 2. At this point, you can try the 2 do now problems at the bottom.